Hey everyone, very good to meet you all here today. So today I'm here to talk to you about how we ship JavaScript in Microsoft. So if you want to contact me, this is here. I come all the way to Norway to tell you today about JavaScript. So that tells how excited I am. So to start, I will start with two stories that will serve as introducing a metaphor that we use a lot in Microsoft. So the first story is about a woman called Jessica. She's an accountant, and she has identified that there is some inefficiencies in the way she does work, and many accountants do work. So she has an idea of a piece of software that could improve dramatically that issue. So she decided to go into it as a side project to learn programming and go straight to it. So this is the process she starts following. So she had this bright idea. She goes to implementation for a year or two. It takes a lot of time to learn programming, and then finally version 1 is out. And so a lot of fellow accountants are using and loving this piece of software. So it's released, everyone is happy, and there's a lot of feedback coming in, most positive. And some feedback talk about some bugs that need to be fixed. Some other feedback suggests how the software can be evolved further. So she decided to not stop here, but to keep working on that product since the feedback was so good. So she keeps going, and she introduced in her process a new step, which basically digests all the feedback received and decide what to do with it. And so the version 2 is released a year later, after all the bug reported were fixed, and after all the features asked were implemented. And this time, the feedback from the community was way worse than the first time. And so what didn't go so well this time is the time between version 1 and version 2. So Jessica, since this is a side project and she's learning programming as she goes, it's taking a lot of time. So there was a year before version 2 came. And a lot of the feedback says, this bug that I reported a year ago seems trivial to fix, but I had to wait a year to get that bug fixed. So Jessica understands that feedback and adapt slightly her process to release new versions on a faster cadence that will only contain bug fix, to be able to provide a quick, to increase the quality of the software without having to wait a full year. And so version 2.3, eventually after 3 iterations, version 2.3 is out. The feedback starts to raise, so the quality is coming to raise, but still there is a lot of feedback about bug and about regressions especially. And Jessica realizes that she doesn't have any consistent testing mechanism in regression. So she implements consistent testing with a mix of manual and automated testing that will guarantee that nothing gets regressed and that the feature gets properly implemented. And so version 3 gets released, and the perceived quality of the software keeps increasing. But still, there is some feedback that now there is very few bugs, but some of the features that get implemented are clumsy and they don't really reflect the needs that were expressed in the feedback in the previous version. So she decided to change her process again to introduce a prototyping stage in which she will validate that she properly understands the feedback and the need behind it before investing in the implementation of that new feature. And so that was the first story, and I wanted to tell that story to introduce the metaphor of a loop, which is a metaphor that we use a lot in Microsoft to iterate over our engineering systems. So a loop, we define it basically as focusing temporarily in 2 or 3 steps of the full process to make sure you get a better quality out of these 2 steps before moving forward. And this brings us to the second story, which is more personal and more real than the first one. So last week I was in France together with my father, and I was observing him typing a mail on his computer, and he went like this. He would type a sentence staring at his keyboard, and then at the end of the sentence, he would look up, look at the screen, reread the sentence, which would consistently have a typo in the middle of it, and then in one way or another go fix the typo, and then write the next sentence. And it was very tedious for me to look at because it felt very, very slow. Even though he was typing quite fast, he had to remove a lot of things. So in the end, the throughput was very low. And I really feel like he should help himself with a better process. And me thinking about loops all the time, I was thinking, what is the loop happening here? And the loop happening here was the feedback between writing a sentence and validating the sentence, then correcting the sentence, validating the sentence, and so forth. And I thought to myself, if we made that loop faster, can my dad type faster and have less overhead in correcting mistakes? So I'm thinking, like, what if he typed a word? Maybe I could suggest to him that he type a word, then verify that word, and then before typing the next word, because then he would not have to delete a lot of words or use the mouse to move the cursor around. But then I realized that it would not work because, I don't know if you tried, but moving the eyes between the keyboard and the screen every word is extremely uncomfortable and painful for the eyes. So actually, even though that loop sounds like it will be more productive, it will be very uncomfortable. And that's the reason why my dad doesn't validate every word, but only every sentence. So the point of this story is that loops are a fantastic tool to help us improve our agility and do what we want to do faster, but they need to be the right size. And as a small loop is often the best solution, it is not the best if it's not supported properly by the tools or by the skills. In the case of my father, he didn't have the touch typing skills, which made the small loop too uncomfortable. So that brings us to how we use that metaphor in Microsoft to improve over the way we deliver JavaScript apps. So I work in Office, and so we ship Excel, Word, PowerPoint, SharePoint, OneDrive, Outlook, all this as native apps, but also as JavaScript apps. And so all these apps currently have their own repository that are represented as cloud here. And so the team I joined when I joined Microsoft was his mission was to make some shared components that could be reused across all these different JavaScript apps to provide a consistent user experience for the end users of Office. And so the way we went about this is create yet another repo called Midgard, which will be like a library repo, which all the other repo could take a dependency, just to have a single source of truth for the logic of these components. And so we'll look how it was for Midgard developer to ship code to these various apps. So this is the process that was going on initially. So you see that there is Midgard which on the left, which is the library repo, and Outlook Web, which is an example of one of the multiple application repo. So as a Midgard developer, I would write my implementation in Midgard, check it in the main branch so that it gets released to a private NPM registry. And then once this is done, I could go check in the code in the Outlook Web repository or any other app repository, and then pull that new dependency and test the integration. And if there was a problem, I would go back to stage 1 and iterate like this. we didn't keep it like that too long because it was obviously very tedious. The iteration loop was way too long. And so, as I said, we love the metaphor of loops and we use it all the time. And to make sure this metaphor sticks a lot, we give names to loops. So this loop of iterating between Midgard and the application repo, we call it the integration loop. And so our integration loop was extremely frustrating and slow. So we introduced a smaller loop by introducing test apps. So test apps were a small application, either a Webpack dev server application or a Metro app that would simulate the integration point in our app, so that the test app was aiming at giving us confidence that if our component behave well in the test app, they will equally behave well in the application. So that accelerated a lot the iteration loop, because suddenly the test app would run on our laptop. We could validate a lot of behaviors without needing to publish anything to master. So we created web test apps to simulate the integration point between our components and the apps, Outlook, for instance. And we have many integration points in many different repositories. So which led us to having multiple test apps that will specifically simulate one integration point. So we end up in Midgard having multiple test apps. And some of them are iOS test apps or Android test apps, since we ship code using React Native. So obviously the iOS test app is a different test app than the web test app. And so we had that constraints that at the time, Outlook iOS was using a different version of React than Outlook Web. So we needed to find a solution, because we need to have two test apps in the repo that works in two different versions of React. So that's when we introduced workspaces to Midgard, the feature that was introduced by Yarn, and which allows in our repo to split our code into small workspaces which have their own dependencies. So that allows us to have the Outlook Web depend on one version of React, and the Outlook iOS test app depend on another version of React. So introducing workspace changed everything in the way we developed. And the first thing it changed is that suddenly, as a web developer, I would not run and validate the entire code base, but only the one that were relevant for my test app. So which means locally, I will actually do less work, more specific work, and then we'll have build agent on that will validate that the entire repository works well. So we introduce a second loop here, where locally we'll test what we're really working on, and then on the cloud we will validate that my code change is not breaking anything else in the repo, that I may be shared code with what I'm doing. And so these two loops have names as well. We call them inner dev loop and outer dev loop. And so to try to make this loop as comfortable and as efficient, we use a lot of tools, a lot of open source tools. So this is a list, not a full list, but some of the tools we use to make these loops very comfortable. And so I'm going to dive into two of these tools here today. So workspaces, as I say, change everything, because it was such a great abstraction to create modular code with encapsulated implementation and clear interfaces. So we use that as an architectural tool to be able to produce cleaner code, and that led us to creating packages way more than we had test apps. So we didn't only have a workspace for test app, but also for small independent piece of code. So we ended up with a big dependency graph. We currently have 900 workspaces. And so obviously, as a developer of Midgard, I'm not going to build or test all these 900 workspaces. I'm only going to build and test the ones that are relevant for the component that I'm developing into. So we have that feature of filtering the dependency graph to only the ones that are relevant to me as I develop locally with my with TypeScript and with the Webpack Dev server. And then our build agents will need to validate that my code change doesn't break anything in the repo. So even though locally I only focus on a few workspaces, the build agent should see the big pictures and validate that everything works well. So I'm going to show how we did this on the build agent by simplifying this picture to only four workspaces. And we use Lerna to orchestrate this. And that helps us to save our build agents some work and to only build and only test what's necessary. So in this example, if I am submitting a change to the workspace A, Lerna will compute which package or which workspaces need to be tested, which workspaces need to be built. And Lerna will also orchestrate the build tasks in a way that in dependency order. So in a way you never build a workspace before being done building all the dependent workspaces. So we use Lerna, and as I say, we scale to today 900 workspaces. And the way we were doing this with Lerna didn't scale in the way that the build became very, very long, up to 2 hours. So we had to find something better, and there was a lot of opportunity for optimization here. So that's what we did. And at the time, we didn't find anything satisfactory for us, so we created a tool called Lagger. And maybe you heard of Lagger. Lagger contributed to the inspiration of TurboRepo, which you may have heard recently. So this is our evolution, which is open source, which is our evolution of Lerna, which adds the feature of build caching and better scheduling, so better utilization of the core, so we can actually do more work faster and finish the build faster. And so that's where we are today, but we're investing massively in our journey to improve dev experience and eventually the quality of the apps. So what we currently invested into is to reduce that integration loop, because though the test app reduced the need for the integration loop is still needed, as there is complex integration scenario that cannot be easily duplicated in the test app. And the integration loop is currently as painful as I saw in the slide earlier. So what we're doing now is we're a big effort to merge all these repos together. And I don't know if you realize, but a single repo having the code for Outlook, Word, Excel, PowerPoint, SharePoint, and OneDrive, and more, it's a lot of code. So with that comes a lot of scaling challenges. One of them is the source control, Git. So we actually had to do some contribution to Git to be able to scale further with sparse checkout. And so we invested massively in doing a lot of work in Git, and here you see a PR of our work. This is in the Microsoft fork, and this is eventually going to be merged upstream to the official Git. Another work we're doing that I'm very excited about is the work on NPM. As we merge repos, we realize that the complexity of the dependency graph makes the install time exponentially high. And so we decided to use a different installation strategy, which has been brought by the package manager PNPM. And we're bringing that installation strategy to NPM, so everyone in the ecosystem can use it. So we've contributed an RFC to the NPM project, which got accepted, and now I am actively working on getting that feature implemented and shipped. Another aspect we are investing into is a tool called Build Excel. So we're investing into moving to Lagger, from Lagger to another tool, which is also open source, called Build Excel, and which allows us to distribute our build across multiple machines, and also allows us to have a finer grain caching. So we can have a higher cache hit ratio when we run our build, leading to shorter build time. So there is a small list of other ways other areas we focus on to make our loops as much comfortable and valuable as possible. So if any of them is a topic of interest to you, I'll be around. I'm very happy to discuss with you today. There are some links about what I've talked today. Thank you very much.